SpaceX is preparing for its most daring step yet, landing Starship Super Heavy at sea. This isn't a stunt, it's a calculated move that could redefine rocket recovery and global launch logistics. Backed by new FAA filings and confirmed by Elon Musk himself, the plan has caught the attention of NASA and Blue Origin alike. If it succeeds, it could reshape the future of space travel. Let's dive right in. When Elon Musk confirmed that SpaceX would attempt to land Starship Super Heavy at sea, the news spread through the aerospace world like a shockwave. At first, some called it risky. Others said it was pure genius. But one thing is certain, this decision will completely reshape how humanity launches, lands, and recovers rockets. Because this isn't just about testing new technology, it's about building a scalable future, one where rockets no longer depend on crowded launch pads or government-controlled coastlines. And that's exactly what makes this move so disruptive. SpaceX's long-term strategy revolves around one thing: high-frequency, low-cost access to orbit. To achieve that, the company needs more than just powerful rockets. It needs flexibility. Starbase in Texas is already at capacity, with projections showing up to 100 Starship launches per year in the near future. Bottlenecks are inevitable. Every delay, weather, maintenance, or logistics, slows the entire system down. That's why SpaceX is looking toward the ocean. Offshore landings reduce risk to people and infrastructure, cut turnaround time, and open the door to continuous global launch operations. Instead of relying solely on land-based sites, Starship could recover anywhere: the Atlantic, the Pacific, or even near the Indian Ocean. The logic is simple but brilliant. The ocean becomes SpaceX's infinite launch and landing zone. Turning that vision into reality, however, requires rethinking every engineering standard that came before. Starship's Super Heavy booster stands over 70 meters tall and generates more thrust than any rocket in history. The Falcon 9 drone ships, like a shortfall of gravitas, are simply too small and too weak to handle that kind of force. So SpaceX is quietly developing an entirely new fleet of reinforced ocean platforms designed exclusively for Starship. Each platform will likely include stabilizing thrusters, heat-resistant decks, and advanced AI-guided positioning systems to keep it perfectly steady in rough seas. This isn't just about building bigger ships. It's about building smarter ships. Each one must handle the tremendous downward pressure of Raptor engines and maintain balance even as millions of pounds of thrust descend onto it. If SpaceX pulls this off, the cost savings will be staggering. Falcon 9's reusability already cuts about $20 million per flight. Starship's full-scale reusability could multiply that several times over. A revolution in space economics. While everyone talks about landings, few realize that SpaceX is already building the logistics backbone behind this ocean operation. With the Florida expansion underway, the company plans to ship Starships from Texas to Cape Canaveral by sea, a journey of over 1,000 miles. To do this, SpaceX is constructing a custom-built vessel capable of carrying the 120-meter rocket horizontally, fitted with vibration dampeners, corrosion-resistant coatings, and structural clamps to secure the rocket during high waves. Until the Florida-based Gigabay factory is completed in 2027, this will be the lifeline connecting Starbase to Space Coast. In other words, Musk isn't just preparing for sea landings, he's turning the ocean into part of Starship's infrastructure. It's not just a recovery zone, it's a transportation network, a mobile factory, and eventually a floating launch system. But there's another dimension to this story, one that goes beyond technology. By operating in international waters, SpaceX enters a complex geopolitical arena. Ocean recoveries may occur within exclusive economic zones of other countries. That means diplomatic permissions, environmental assessments, and legal coordination at a scale no private company has faced before. According to early reports, SpaceX has already opened channels with Australia, Brazil, and Argentina for potential recovery corridors in the Pacific and Atlantic. Each partnership would bring mutual benefits: access to cutting-edge technology for these nations and greater global reach for SpaceX. If confirmed, this would make SpaceX the first private company with international maritime recovery rights. That's not just engineering progress, that's global influence. Meanwhile, over at Blue Origin, the mood is tense. After the failed landing of the first New Glenn booster, Jeff Bezos' team is racing to regain credibility. Their next flight, scheduled for November, will carry 2 NASA satellites to Mars, and it's being described internally as make or break. But here's the reality. While Blue Origin is preparing its second major test, SpaceX is preparing its 11th Starship flight, with ocean recovery already in motion. That's not a small gap. It's a generation gap. SpaceX iterates, tests, and improves at a pace Blue Origin simply hasn't matched. And as Musk builds ocean-based recovery infrastructure, Bezos faces the uncomfortable truth that SpaceX is now playing an entirely different game, one focused on mobility, speed, and global scalability. It's no longer about who builds the biggest rocket. It's about who can operate without limits. Even within NASA, there's a mix of admiration and concern. The agency depends heavily on Starship for the Artemis lunar program, and every modification to Starship's recovery system requires new simulations, risk assessments, and regulatory reviews. Yet many inside NASA privately acknowledge that if SpaceX succeeds, the payoff is enormous. Ocean recovery would allow Starship to complete longer, more complex missions, including returns from lunar orbit and Mars transfer trajectories, without being limited by fixed landing sites. Some engineers even speculate that future lunar refueling and re-entry systems could be based on the same ocean platform technology now being tested for Earth. What seems experimental today could soon become the backbone of NASA's deep space logistics. Elon Musk has a history of solving the right problem before anyone else even sees it. This time, the problem isn't rocket performance, it's launch capacity. By moving operations offshore, SpaceX can bypass land-based launch restrictions, weather shutdowns, and political interference. The ocean gives Musk flexibility that no government agency can control. It's the same philosophy that built Starlink. Create a system that's decentralized, resilient, and independent. And that's exactly what the ocean-based Starship network will become. A self-sustaining, borderless launch ecosystem. For the first time in history, humanity could operate a reusable rocket system from anywhere on Earth. Of course, none of this comes easy. Landing a 5,000-ton rocket on a moving ocean platform pushes every limit of engineering and physics. Even with modern sensors, the challenges are extreme. Changing wave patterns, unpredictable wind shifts, and engine precision that must be accurate within centimeters. Starship's methane-fueled Raptor engines also introduce higher combustion energy than Falcon 9's kerosene engines. That means stronger blast shields, advanced water deluge systems, and new risk management protocols. But this is where SpaceX's advantage shines: iteration. The company doesn't fear failure, it learns from it. Each flight refines the model, improves the algorithms, and brings them closer to perfecting autonomous sea recovery. And according to internal sources, the next generation of AI-guided landing software will integrate real-time oceanic data, tracking every wave, current, and gust, making split-second corrections thousands of times per second. If that works, the implications go far beyond Starship. It could revolutionize autonomous vehicles, drone delivery, and even Mars landing technology. Here's the twist most people miss. Musk's ocean platforms aren't only for landing, they're also designed for launching. SpaceX's ultimate goal is to create floating spaceports, capable of launching rockets from anywhere in the world, away from cities, noise regulations, and geopolitical constraints. Once a Starship lands, refuels, and reloads on the same platform, it can launch again within hours. That's the foundation of Musk's rapid reusability dream. A true fly, land, refuel, fly again system operating 24/7 across the planet. It's not just efficient, it's revolutionary. This is how you build a space economy that never sleeps, one that turns Earth's oceans into gateways to the stars. While SpaceX is looking outward, Blue Origin is still trying to find its footing. The company's engineers are addressing 7 major flaws discovered during New Glenn's failed attempt, from propellant instability to engine bleed control. Blue Origin's new CEO, Dave Limp, has publicly said the mission will take luck and flawless execution. That phrase alone tells you everything. SpaceX doesn't rely on luck. It relies on data. And that difference explains why SpaceX has completed over 500 successful booster recoveries, while Blue Origin is still chasing its first repeat success. This gap isn't measured in launches. It's measured in momentum. Now, as Starship Flight 11 marks the close of the version 2 era, SpaceX is already preparing for version 3, stronger, faster, and optimized for high-volume reusability. Ocean recovery is expected to debut in mid-2026, following several test flights and precision re-entry trials. If successful, it will make Starship the first fully reusable two-stage rocket system in history, capable of global operations from both land and sea. And that's the real point here. This isn't just a new landing technique. It's the foundation for the next chapter of human spaceflight. One built not on national borders, but on global cooperation, engineering discipline, and the relentless vision of a man who refuses to think small. Because for Elon Musk, the ocean isn't a limit, it's the next launch pad. And this is exactly why Musk's ocean move changes everything. It's not just about landing a rocket. It's about building the foundation for global, reusable spaceflight. SpaceX is proving that reusability doesn't stop at the launch pad. It extends across the world's oceans, and when that system works, it could redefine how humanity reaches the moon, Mars, and beyond. The next phase begins soon, and every successful test brings us closer to a future where rockets operate as routinely as airplanes. What do you think? Is this the smartest move SpaceX has ever made, or its biggest risk yet? Share your thoughts in the comments below. If you found this analysis valuable, like the video, subscribe to Space Hub, and turn on notifications so you never miss the next breakthrough shaping our future among the stars. This is Space Hub, bringing you real insight, real progress, and the story behind every space revolution.